Hey, this is Mike with Peter's Industry Training and Consulting. Today I want to talk about function blocks, and for those of you that already watched my video that I created before, this is basically what we did last time with the operating hours. We just copy that that whole function into a function block. And the difference between it is pretty much like when you create a function, this will be executed one time and only for one reason that you created the function for, and it's not really reusable other than you just copy and paste it and then use it for something else to count something else. With a function block though, you can create a function and then reuse that function all over again all the time for whatever you want. In our case, we're counting operating hours. So let's say you want not only count the all over time for the CPU, like with the function that we created in the last video. Let's say you want also to count operating hours for different other devices or other functions, and you don't want to write too much code, or you don't want to program too much functions. And that way you just create a function block and reuse it all over again with every device you want to count the operating hours, for example. In our case, we use that as a simple example. You can see that here. For all of you who didn't see the last video, I recommend to go to my channel and watch for the video called Functions, and then you can go through that and then create what we created in the last video, and you're on the same page that we are right now. So let's dive right in. Let's create a function block. So you go on Add New Block, this time function block, give it a name. In our case, it will be operating hours counter, and then it will create in automatic FB1, or you can put it on menu and give it whatever number you want. We also, again, we use the ladder diagram just to make it more graphic for everyone, and then go ahead and create it. So the difference between a function and a function block, as you can see, even though the function has its own data here too, the data in the function block is a little bit more than the data in our data blocks in general. So you have the accessibility and visibility in the HMI. Put that up, and you have set points and comments and stuff like that. And yeah, let's create our function block. We actually pretty much copy our function from the last time. Just this time we have to create inputs and outputs and static values within the function block, just to make sure we're on the safe side. So let's first create the inputs. So what we want to do is we want, for example, when one device is active, we want to have a trigger for that. So we say, okay, let's say device active, and we want it to be a bool. Then that's actually pretty much everything we need as an input, and we need an output, and we need seconds, we need minutes, we need hours, and we need days. All of them have to be an integer, of course, because it's full numbers. Okay, and then we also need a couple of static values. In our case, for example, we need a trigger counter that's a bool, and then we need counter seconds. That will be an integer. So, and then we also need, whoops, where are we? Here. Counter minutes, counter hours, counter days. Okay, what else do we need? We need something, well, as you know, out of our function, we need a positive trigger in order to count the 1 Hertz clock, and but this time you can't use a global memory, you have to use an internal memory for that. So what we do is we create one, just pause trigger, and we can use that will be a bool. We can use that within our function just to make sure we don't use global data within our function other than the inputs that we created here. So let's start, and what we do actually is just making sure we can copy the function that we did last time. We just use the internal data instead of the global data that we use in the function. So we start with anomaly open, say okay, we want device active, and here you can see the internal data is marked with a pound sign before it. So here you have global data that's marked with whatever it is, memory or inputs or outputs or whatever. So we want to use the internal data, device active, enter, and then from here on we kind of copy our function. So what we say is, okay, we want to have normally open, and then we use, that's the only global thing we use, that's the clock 1 Hertz. That's like giving us a signal every second. And then what we want to use is a positive trigger, and this time we use the internal one, plus trigger, so that we don't use any global data. And then we want to do something, and that is we want to trigger our counter. Did we create that? Yeah, trigger counter. So we go there, trigger counter, so enter, and then in the next network we use that trigger counter, and say, okay, every time that is triggered we want to do something. And like we did it in our function, we say, okay, every time we have this trigger, we want to add to counter seconds, we want to add 1 and put it back into counter seconds. Pretty much the same that we did in our function, just now we're using the internal data. So next network, we say compare counter seconds to 60, then do something. In our case, we want to say we want to reset something. Did we create that yet? No, we didn't. So we have to create more data. That's reset seconds, reset minutes, reset hours. That's pretty much it. So now we can use it and then say, okay, when counter seconds equals 60, then we want to reset the seconds. So put colon, reset seconds, and then the next network, every time reset seconds is triggered, we want to do something. We want to move 0 to counter seconds, and we want to add to counter minutes 1. and put it into counter minutes. So, and then again compare counter minutes with 60, and then coil reset minutes. Reset minutes. We'll make sure we move 0 into counter minutes and add to counter hours 1 and put it into counter hours. So again, compare counter hours to 24, and then reset hours. Reset hours does move 0 into counter hours and adds to counter days 1 and puts it into counter days. Oh, that was not right. And add counter days 1 to counter days. Okay, so what we have now, our function set up. What we didn't do is give it out of the function block. This will count, but all the data will stay within the function block. What we want to do is we want to give it out. We created the outputs already. Where is it? Here. We have an output for seconds, minutes, hours, and days. So what we're going to do is we move, and that is unconditional. We just want to move it all the time to the output. So what we're going to do is move counter seconds into seconds, and then again, and at the same time we want to move counter minutes into minutes. At the same time, that was not right. And move counter hours into hours, and move counter days into days. So that's pretty much it. So we are now already done with our function block. So we can, because we didn't use, other than the input of device active, we don't use, and the clock of course, we don't use any global data. We only use the data within our block and then give it out to our outputs, whatever it is, seconds, minutes, hours, or days. So what we have to do now is just with our function block, we don't have nothing would happen here because we didn't put any input in it, and we didn't ask for an output yet. So what we're going to do is we create a function. Don't forget to save. We create a function for calling that function block, and we can within the function we can call that function block as often as we want and for whatever we want. So let's create add another block, this time a function. Say we call it operating hours devices. So put it in automatic, or what, give it whatever number you want, put it into ladder diagram, and then create. So now we have our FC2, or whatever you called it. So what we're going to do is, first we want to make sure, okay, we have devices, because we're only using the simulator, the PLC sim, and don't have any input from outside. We just use the global bits that we talked about before in the device configuration. You have the system, where is it? Properties, system and clock memory, and we enabled that in the last video. So we use always one, always true. That's M1.2 to make sure we have a device, or we have an input for a device active. And we do that in our function and say okay. We say normally open, and then we say always true, activates device 1. No, that's not right. Device 1. Okay. Enter, and then it gives you the red underline. That means that tag is not defined yet. So make a right click on it, and then say define tag, and say okay. So it will automatically give it a address. You don't have to do anything other. You want that, but for now we just stick with the recommendations of the TIA portal. We define the tag, so we have device 1 active because this is always true. So what we do now is we just copy that. Whoops, just copy that. Copy, and then click on here, paste. Click on here, paste. Click on here, paste. So the only thing we have to do is now, because it's all device 1, we go ahead, click a couple of times in here, say device 2, enter, enter, define tag, define, device 3, define tag, define, device 4, and do the same. Right click, define tag, define. So now we have our 4 devices kind of like created. It's not really a device, but it's just it works for us right now. And then what we want to do is we want to call our function block within this function, and we want to call it for each of these devices. And the way we do that is go in a new network, mark that here, and then put an empty box in, click in it, and say FB1, and then just enter, enter, and it will create a single instance data block, because every time you call a function block, it will create its own data block, an instance data block. So just to make sure that every called function block has its own data and it's not interfering with one of the other function block instances. So let's go ahead, create that. It will create it here. You don't have to touch it. The data is already created by the function block. So what you do now is, okay, say, okay, our input is device active. We want to say device 1, and then our output will go in whatever we want it to go. I already created device 1 through 4, and then all the different seconds, minutes, hours, days for each of them, just to shorten that video up a little bit. So what we're going to do is we say, okay, we want to times device 1 seconds, and then for minutes the same. You want times device 1 minutes, and then for hours times device 1 hours, and of course times device 1 days, and then go ahead if you want to. So we created our first calling of this function block, and then you can go ahead and say, okay, I want more of these, and say, okay, empty box, put it in again, FB1, enter, and then it creates a new single instance data block for you. You don't have to do anything, just put it on automatic. That's okay. It calls it like your FB is called, and then calls it just a number. So here you see, okay, that's the DB, the DB, the real DB number variant, but it calls it DB1 because that's the second instance. So it always starts with no number and then 1, 2, 3. So that should be okay. And then you can say, okay, this one is device 2, and then also times device 2 seconds times device 2 minutes times device 2 hours times device 2 days. So it will now, even though we use the same function block, it will only count in this one, in this instance, it will only count if device 1 is active, and will give the outputs to times device 1 seconds, minutes, hours, and days. And this one will only be active if device 2 is active and gives it out to the seconds, minutes, hours, and days of device 2 that I created in our data block times. So that's pretty much it. If you now go ahead and say, okay, I want more, I want all my 4 devices, just go ahead. I will stop that video here and fill it out for you so that that video is not that long. 1 sec. Here we go. So now that we're gone, we don't have to call the FB, OB1, because this is not necessary for FBs. You call them wherever you want them to call, and that's fine. So we call them here, all 4 of them. We have all our data in place. Let's see how that worked out. First of all, if you didn't start your simulation yet, do it now. Click on here and then load your program into your PLC sim, and then we can see what happens. So in my case, I already did that. The only thing I have to do is download everything. We say, okay, we want to reinitialize. Okay, something's wrong here. Let's see what it is. Save project. Compile. Software changes. Oh, okay. This one. Save. Now download. Okay, reinitialize, load, finish. Okay, it's in there now. What we can do is we're going on our operating hours, devices, and see what's going on here. Let me see better. Oh, see, we forgot something. We didn't call our function. We don't have to call a function block. What we do have to call our function. So go to the main OB, say call FC2 and download. Yes, we want to override it. So now go to your function monitor. Here we go. So because this is always true, we set our devices all to true. And if you go down here, you can see true. That means it counts. Also with the next one, it counts. Also with the next one. And the very next one. So what we can do now is in order to check if everything is okay and it only counts when a device is active, what we can do is we say, okay, we say this here should be always false, and then this here also should be always false. And then download it to your simulator. Yeah, all right. And then you can see now it's set to false, so device 1 is not active. That also means that because this is inactive, this doesn't count. So when you have a device like a motor and you want to monitor the operating hours of a motor or something, every time that is off, it won't count. So when you create a memory for that device to be on or off, you can stop counting or give it back to counting. And even if you shut down your CPU, if you set it on retain the outputs, here it's on non-retain. If you set it on retain, even then it will be still in your memory whenever you fire that CPU up again. So what else do we need? We need to have the counters retain, otherwise it will start from 0 and move your zeros or whatever in your output. And even if your output is retained, it will override it. So you put all that to retain and you should be good. So now we have differences here. What we're going to do is like just download, no action, reinitialize, load. So while we with the initializing, we set our data all the time back to our default values. With an integer, that's if you don't define it otherwise, it's always 0. So we start new. So every time you reinitialize something, it sets it back to your default value. So in our case, we want to monitor our function now. Okay, still monitoring. And now this one is false, so it doesn't count. It's all set to 0 because we reinitialized it. This is true. 45 seconds yet since we restarted. So, and then just to test if we did it right, we can go ahead and say, okay, we go into our in our FB and say, okay, we want to monitor that. Actually, we don't go into the FB, we go into the instance data block of the device you want to manipulate, and then go to monitor. So you can see, okay, we're at 30 right now, 1 minute. So we want to say, okay, we are not like modifying the output, we are modifying the static values. So we go ahead and say, okay, we want to have modify operand 23 hours, and we want to have modify operand, we want to have 59 minutes, and we want to have 55 seconds. So now, as you can see, it should move here. See, now we have 1 day, everything else was reset, and it counts again, so everything works. And because we're using the FB, you only have to test that once because everything is the same. So if one FB is working, then everything is working. So now we accomplished pretty much the same that we accomplished with our function in the video before, just with a function block, and we can reuse it for different devices or whatever you want to count. In our case, we just like stick to the easy task of counting operating hours, just to show you a little bit what it is like to count something, to move something, to create a function block, to use data. That's not the most advanced task, I know that, but we're starting from scratch here, and that's for all of you who are not so familiar with PLC programming, and everyone who is already a PLC programmer and is looking for something to learn. I think that's not the right course here for you. This is really for absolute beginners, and we're starting from scratch, and we are processing more and within more videos, but for now we're really starting from scratch. So I'm sorry about that, but you maybe might not learn anything here. So this is it for today. Just leave some comments, tell me what you think about that, if that was helpful. Also, don't forget to subscribe for new videos, and I would say see you in the next video. Thank you.